All right, geometry. So this is actually a big set of notes. This is I'm combining 4, 2, 4, 3, and 4, 6 in these notes, and this is on what's called triangle congruence. Triangle congruence is a major topic in our course, and this is where the majority of your proofs are going to be. So we did some parallel line proofs, honors. You've done some isosceles triangle proofs. Those are all just warm-ups. These are the proofs that we really care about. And what's nice about these proofs is there's much more of a format to use when you do them. However, a lot of different ideas can be brought into the proof. So you have to know your geometry. So if you remember from the very first day of this class, I wrote vocab, vocab, vocab. That is so important. You have to know the ideas and be able to apply them. So first off, let's talk about what it means to be congruent, okay? So there's a lot of words here, but it says if two triangles have 3 pairs of congruent corresponding angles and 3 pairs of congruent corresponding sides, then the triangles are congruent. So right here, we have the 3 angle pairs, 1 letter only, so these are the vertices of each angle, and we have 3 side length pairs. So these are your 6 pairs of congruent parts. 6 congruent parts. 3 angles, 3 sides. Over here, they're all marked, right? So notice F and J are red because F and J are corresponding vertices. They're congruent angles. G and K are blue because they're corresponding vertices. Their angles are congruent. H and L are purple. Their corresponding angles. Their angles are congruent. And then notice F to G is 1 dash. J to K is 2 dashes. Those sides are congruent. GH is 2. KL is 2. Those sides are congruent. FH, JL, 3 and 3. Those sides are congruent. So if you know the 6 corresponding congruent parts are congruent, then you know the triangles are congruent. And again, notice how the triangles are named. They're not just named in any order, they're named in corresponding order. F to J, G to K, H to L. And this is not necessarily not alpha order, right? It doesn't have to be alpha order all the time. It could be, but it's not always alpha order. It's correspondingly. All right. So I could actually put F to the end of this triangle, but I'd then have to move J to the end of the second triangle. Now, this is an important idea here. It says, however, this is more information about corresponding parts than you need to prove the triangle is congruent. So we're going to talk about, instead of knowing all 6 parts, is there a simpler way to go about proving triangles congruent? Well, let's see. All right, so we have here 2 postulates. Remember, postulates are statements you have to believe that are true. First one is called the side-side postulate, or SSS. This says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So notice here, side, 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 side. SSS. If you know 3 sides of one triangle are congruent to 3 sides of another, then the triangles are congruent. Boom. We also have an SAS postulate that says if you know that 2 sides and the included angle, so included means the angle in between, are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Side, angle, side, side, angle, side. So notice that angle is in between the sides. If you know this information, then the triangles are going to be congruent. All right. But now I'm going to explore this real fast. There is no SSA congruence. So we take that angle out of between the sides and put it after a side. Again, this is because you cannot guarantee congruence. I'm going to show you here with an example on Desmos geometry. If you take pre-calc, they call the SSA situation the ambiguous case because there's a couple different cases, and there's sometimes more than 2 triangles that you can create, like I'm going to show you here. So I'm going to create a triangle that has a side length AB of 3, BC of 4, and angle C is 30. So I'm going to write them here if I can. Yes. So AB is going to be 3. BC is going to be 4, and the measure of angle C is going to be 30 degrees. So this is going to be triangle ABC with these things. So let me see if I can do that right now with that shown. I think I can. That's awesome. Yep. Okay, so quickly, here's my triangle. Let's label A, B, and C. So A, if you go in order, it's good. B and C. Okay, so let's label AB with its length. So it needs to be 3. So I'm going to shrink that a little bit. There. Let's label BC's length. Okay, it's got to be 6.46. I'm not going to move A or B. I'm going to move C to make this 4. Boom, good. And now I need angle C to be 30. So I'm going to measure angle C. If angle C is my angle, that means C is the vertex. That's the second letter I choose. So B, C, A. And now I got to make angle C a little bit bigger. So watch what I'm going to do. I'm going to move A in this fashion. I'm going to bring it down to open up angle C. Now notice that this side length is changing. But now I think I can get it close. There. Oh, so close. How am I doing? Good. So there's my picture, right? Let me draw it up here. So there is a triangle, okay, that has sides of 3, 4, and this angle of 30. And this is a side angle case. And again, the reason is because of this side angle. So now keep that vision in your head and watch what I'm going to do right now. I'm going to take A and I'm going to slide A alongside AC, right? So watch this. So I'm sliding it, sliding it, sliding it, sliding it, sliding it. Closer, closer, closer to C. As close as I can get. Boom. Look what I just did. I just made AB 3. I made BC 4 and angle C 30. I made the same exact 3 things. But now look at this triangle. Is that triangle congruent to the first triangle? Let me see if this undo works. Right, that was the first triangle. And now if I redo what I just did, there's that triangle. They're not congruent. So this does not guarantee congruence. This is actually the 2 triangles case. Okay. So I need us to try to remember desperately, right? Desperately, that SSA is not one of your congruences. Okay. And if you spell it backwards, just saying, don't be that kind of person. Okay, good. All right, that's this video. Second video coming with more notes.